In this question, we are told that a drama class has sold tickets to the spring production for the last several years. From experience, they know that they can sell 360 tickets at $20 per ticket. But they know they would sell fewer tickets if they increased the price. If they would sell 10 fewer tickets for every $1 increase in price, what should they charge to maximize their return? So it says, first of all, if the number of $1 price increases is defined as 1x, or really just x, the new ticket price in terms of x is, so we're talking about taking a $20 ticket and adding $1 each time, so we'd have 20 plus x. Next it says, and the number of tickets they would sell would be, so we know that we would sell 360 tickets to start with, and every time we increase the price by x, we're going to sell 10 fewer. So if we increased it by, let's say $1, we'd be selling 350 tickets, $2, 340 tickets, and so forth. So we'd start with 360, and then we'd be subtracting 10x. So now that we've come up with these two initial functions, we can figure out our revenue function. So let's start with that. We'll determine our revenue function. Once we have our revenue function, then we can complete the square to determine how much we'll make and the price that we should charge. First, let's start by taking our two initial functions. The ticket price function, a $20 ticket plus increasing it by $1, and the number of people attending, which would be 360 minus 10 of them every time we increase by $1. Now from here, if we use the distributive property, we'll be able to put this function into general form. 20 times 360 gives us 7,200. 20 times negative 10 is negative 200x plus 360x, and then x times negative 10x is negative 10x squared. Finally, gathering our like terms and putting it in descending order of powers, we have our function in general form, r is equal to negative 10x squared plus 160x plus 7,200. Now from here, if we go and complete our square, we will be able to determine what our value is for x, how many increases in price we should do, and what the maximum revenue will be. So just like whenever we complete the square, we need to take our leading coefficient, in this case negative 10, and factor from the first two terms. When we do so, we have left in our brackets x squared minus 16x. Now we'll take this term, the negative 16, we'll divide it in half, which gives us negative 8, and then we'll square it, which will give us plus 64, and then minus 64. The negative 64 will be multiplied by the leading coefficient, negative 10, which will bring it outside of our brackets, which gives us positive 640. Finally, we can add these two like terms, which gives us 6,840, and now we're ready to complete our square. X squared minus 16x plus 64 is equivalent to saying x minus 8 all squared. And so we have our function that the revenue is equal to negative 10 all multiplied by x minus 8 all squared plus 6,840. This 6,840 would be our new revenue. If we increase the price by $8, this will be our total revenue. Finally, because we need to do 8 increases in price, 8 increases of $1, and the initial price was $20, we know that our maximum revenue will occur when we have a ticket price of $28. Finally, let's check our solutions, and we are correct.